so notice and wonder. So what do you see between these two equations? Say it again. Yeah, between these two. They're reflections over the line y equals x, or they're inverses of each other, right? Yeah. Okay. Paris, what else you got? Okay, so they're opposite operations. Yeah. Yes, inverse operations. Go ahead. Yep, the tables are switched up. So what I would write on your paper is this is an inverse function of this. Inverse function. Inverse function. Inverse functions. This is not super bad. The biggest thing is learning how to like put one function inside of the other, which I'll show you how to do that in just a second. Inverse functions is what you're titling your paper. Okay, so what you're also writing on your paper is this little sentence right here. Okay, so f of x and f to the negative first, we read this as the inverse of f of x, or inverse functions. So these characteristics will be true. The inverse function and f of x will reflect over the line y equals x. And then the x and y coordinates are going to be switched. Just like we talked about, the tables are going to be opposite of each other. Okay. Let's take a look at the graph of a quadratic function and its inverse. What do you notice? It's what? Rotated. Okay. So we know that the quadratic has got x to the second power, right? And then we just talked about the inverse function being the square root of x. If we just graph the square root of x, we're going to get this top line. Okay. We won't get this dash line. What is this dash line going to be? Yep. Yep. We go negative square root of x. So there's two pieces that go into it, right? Okay. So fun fact, the inverse function of x squared is not actually a true function because it doesn't pass the vertical line test. Does not pass the vertical line test. If it passes through more than one, it's not a function. It has to pass through 1 point. Okay, so what I would write on your paper is that x squared and the square root of x are inverses, but the inverse function of the quadratic is not a true function. So it does not pass the vertical line test. So I would write this, and I would say the inverse does not pass the vertical line test. Equation, the table, and the graph. Okay, so predict the equation, the table, and the graph. First, let's just do the table. What's going to happen with the x and y's? We're going to switch. Okay, so we're going to write -8, -1, 0, 1. I can't see the last number. 8. And then we're going to have -2, -1, 0, 1, and 2. For the equation, what do you think it's going to be? We had x squared, and then we had the square root of x. So what is this going to be? The cubic root of x. Okay, what's the graph going to look like? Like it's going to be sideways, right? So it's going to be like, yep, like that. You can plot the points. All right. Okay, so to compose two functions means substituting one function into the other. So for instance, if I write out f of x, okay, instead of putting this x, I'm going to put what g of x actually is. Okay, so for instance, I'm going to take g of x and I'm going to substitute it in for this x. You can see that right here. Then they're going to simplify. Okay, they're also going to do the opposite. So what I mean by that is you're going to write out g of x, and then you're going to substitute f of x in for this x. Okay, so go ahead and take a moment. I would write these two things down, and then we're going to do a couple of practice problems with it. Okay, so when you compose a function and its inverse, the operations always cancel out and leave you with x. Okay, so I don't expect you to write this down. I'm just going to kind of talk you through it really quick. So we're going to take the function x squared and we're going to plug in square root of x. So when we plug that in here, and square root and squared cancel out, so you're left with x. So that way we know that these are inverses of each other. Okay. On the next one, if we take the square root of x and then take x squared and plug it in, that's what we did here. Those cancel out and that gives me x. If you don't get x at the end, when you simplify, they're not inverses of each other. Okay, if you don't get x at the end, then they're not inverses of each other. Okay. All right, so go ahead and write these two functions down and we're going to check it. We're going to go through this together. Ready? So what we're going to do is we're going to take the function g of x. So that's this guy. Okay. And instead of writing this x, we're going to write what the inverse is. Okay, so we're going to say cubic root of x minus 4 plus 4 to the third power. Okay, now important part here. You've got to follow PEMDAS. So you do what's inside the parentheses first, and then you do your exponents, blah, blah, blah. So these two things would cancel, and we would be left with the cubic root of x raised to the third power. If I have the cubic root raised to the third power, those cancel, and I get x. So I checked it this way, and it works. So I plug this junk into this x. Oh. So I took this guy and I plugged him in for this x. Yeah. Okay. Let's see. So now we have to do it the opposite way. So what I mean by that is take the inverse function, write it down. And instead of writing this x, we're going to put this junk. Okay, so this is going to give me x plus 4 raised to the third power. And then we're going to have the cubic root minus 4. I just work here. Yes. Yeah, I think we make it a week at this point. So when we simplify, we're going to get x plus 4 minus 4. This will cancel, so we get x at the end. You have to make sure that it works both ways. So you have to do both of these. And if you get x at the end and they're both right, then these are inverses of each other. Is there a symmetrical relationship between a graph and its inverse? Yes. Okay. Slide number 3. Malik says that all you have to do is find a few points on the original graph, then switch their coordinates x, y, and it becomes y, x, and then plot those points. David thinks Malik is wrong. David says inverses are opposites, so you just need to make each point negative. So x, y becomes negative x, negative y. David is wrong. So Malik is correct. Why is Malik correct? He's better. Because he's right. Okay, cool. Remember, it's a reflection across the line y equals x. So that's why those y and that x switch. That actually comes from your geometry. Okay, so if you were to make a sketch of this guy, you would pick your points and then switch your x and y. So for instance, we've got this point right here, that's 0, 2. So this is going to be 2, 0. We got this point right here, that's -1, -1. That's just going to stay. Okay. We got this point right here, that's 1, 5. So that's going to be 5, 1. And if we connect this beautiful dots, that's okay. Okay. Then we have this lovely line. Okay. If you tilt your head to the side, you can see how it's symmetrical, right? All right. So we're going to go ahead and skip to, I really don't think y'all need to practice a whole lot of this. Okay, so how would I find the inverse for this function? I'm on slide 15. Slide 15. Okay, so how would I find the inverse for this function? I'm going to switch my x and y, right? Okay, so I'm going to switch my x and y. And then I would solve for my y. I would get my y by itself. So what's the first thing I'm going to do with this one? There's a take the square root. Okay, so we have square root of x equals 3y minus 4. Now we still want y by itself. So we're going to add 4 to the other side. And so that's going to give me square root of x plus 4 equals 3y. And then we're going to divide by 3. So this will give me square root of x plus 4 divided by 3 equals y. Sometimes this is written with the inverse notation. Sometimes it's given a new name. So for my people who are like steps oriented, the steps for solving for the inverse are going to be switch your x and y. And then step 2 is isolate your y. That's it. So we're looking at Unit 7 CFA. Okay. The first question is going to ask about a solution to a radical function. So my suggestion to you, plug in, yeah, and then check that the left-hand side and the right-hand side work. Don't just check one number. Like for instance, if they give you a solution on one side, if they give you one solution and it works, make sure that it doesn't work for the other option. Like 5, 7, for instance, you need to check 5, and then you need to also check 7. Does that make sense? Okay. The whole thing? He said the solution to the radical. Yeah, solution to the radical. And if they give you an option of like 5, and they give you another option of 5, 7, check that 5 and 7 work. And if they don't work, then just pick the one that says 5. Yeah, vice versa. Okay. The next question is going to be a graph of a radical. I'll get into Desmos. Nothing more to it. Next one is solution to radical. Same thing from the first one, just a different problem. This one's probably going to give you a little bit of trouble. This is going to talk about, if I had numbers like this. Let's do to the third power, 2 to the first, 6 to the negative 4. Simplify. So knowing your exponent rules. Yeah, some of you need to go back over that. Okay, exponent rules. Oh, is it? This one? 2 to the third, 6 to the second, 2 to the first, 6 to the negative 4th. 2 to the first is 2. Times. Okay, this one you're probably going to need to go back and review. Okay, number 5 is going to ask about which one doesn't have a solution. So which one is no solution. You're looking for the equation. I'm just going to tell you right now. That looks like this. It's got a radical and it says plus some number. Because if that's the case, when you move this guy to the other side, it's going to be a negative. And that won't work. You won't have a solution. Okay, so that's the one you're looking for. Or no solution, yes. Right. Okay, the next question has 2 parts, and it's asking about the domain in context. And then when the range is invalid. Okay, so remember, when we talk about domain in context, we cannot have negative numbers. When we talk about domain and context, we cannot have negative numbers. So you can't have like negative hours, can't have negative speed, you can't have negative numbers. Okay, if I ask when the range is invalid, I'm asking for what domain is my range going to be negative? Okay, so what domain is my range going to be negative? That's what it's asking for. Invalid means does not work or does not work in real context. That one's a little tricky, might give you a little bit of trouble. Number 7 is an error analysis. And you're looking at solving radicals. Number 8 is asking about transformation of radical functions. Number 9 is another solving radicals. Yeah, we know. Number 10 is kind of like a blast from the past. It's asking about when the function is positive, and that means that it's above the x-axis. You're looking at the domain. When is the graph above the x-axis? Number 11 is a blast from the past. It's talking about rationals. And you got to simplify this. Remember, our shortcut for number 11 is take the original, plug it into Desmos, take your answer choices, plug it in Desmos. Whichever one graphs over, that's the right one. Yeah?
For number 11?
Yep.
Number 35.
Number 12, the last one. This one's solving for x for rational functions. Remember, plug it in and see if it works. Remember, tomorrow is one of our shorter days. Okay, so when you get in here, we're gonna start quick. Okay, I want you to have the entire time. So we're not gonna have extra time on Monday. Okay, because I don't even see you on Monday. Okay. So you got to get in here and we got to get started. Okay.